right, as we get started today, I want you to start by graphing on your graph paper x squared plus y squared minus 6x plus 10y plus 30 equals 0, just by way of review. Take a look at that in a moment, and then we'll get into today's material. Take a few minutes to work on graphing that conic. You know, if Apple made a conic, what it would be? Iconic. Hey, you want good jokes, pay a comedian. You're getting this for free. Oh, man. The price is right, right? It just popped in my head, so I thought I'd share. Gwen's like, don't share next time, Mr. Dasky, just say no. All right, what kind of conic do we have here for classwork? Class? Circle, how do we know? The x squared and y squared present, and both of them just ones, correct? So the key, remember, in getting the circle to a graph is we have to know two things about the circle. Center and radius. So for that, we need to get to the circle form, and how do we do that, Jamie?
You group the x's and the y's together, and then do the square.
All right, so walk me through here.
Is x squared minus 6x plus 9 plus y squared plus 10y plus 25 equals 30 plus the 34.
Well, careful, it's not a 30 plus the 34, it's
It's a negative.
negative 30. We pick out that constant, so we're going to turn these PSTs into what, Quentin?
Binomial squares.
Binomial squares, specifically.
X minus 3 squared plus y squared.
And then the value over here comes out to just a
4.
4. So we can tell the center is what, Jamie? I think you had this.
3 negative 5.
3 negative 5, but your radius should have been much easier to graph.
4. Or
2, right? And so the center's at 3 negative 5, which would be here. And you would take your compass and open it just 2 units out. And so really little circle here. In fact, almost painfully small when you're doing it at the chalkboard. But this is what we should have had right here. Now, Jamie, in your case, you had the square root of 64, which was a radius of 8, correct?
Right.
Which would have actually been a little easier to draw. But there we go. Questions on the classwork? All right. Let's go to review what we talked about more recently then. And that was graphing, working toward graphing our next conic section, and that was the parabola. What is the definition of a parabola, Quentin?
It's a locus of points equidistant from a line and a given point.
Good. The locus of points equidistant from a given line and a given point. We call the given line the directrix, and the given point is called the focus. The on our parabola, the point at which the parabola changes direction, starts going the opposite way, is called the point on the parabola where it changes direction. It's going one way and then whoop, now it's going the other way. The vertex of the parabola. And if I were to draw a line through the vertex and the focus, that line is referred to as the axis of symmetry. Very good. The distance from the vertex to the focus on the axis of symmetry we refer to as the focal length. And if we were to measure the focal length the other direction outside the parabola, that would be the distance to the directrix. Remember, we go in the parabola to the focus, outside the parabola to the directrix, which is always perpendicular to the axis of symmetry. Through the focus, we have a special focal chord that gives us the width of our parabola. The latus rectum, very good. And we said for a parabola, because it's defined as the locus of points equidistant from a given point, focus, and given line, directrix, the distances to the focus and directrix have to, of course, be equal then. That's the definition of a parabola. If I took those two distances that are equal and set them in ratio, it would give me, obviously, what value then? 1. And we call this ratio of the distances to the focus and directrix for any point on the conic, we call that the eccentricity. Good, and of course it'll always equal 1. Now, a moment ago, we said we saw the x squared plus y squared, and then we had a bunch of other stuff, right? But that x squared plus y squared at the beginning told us circle. How do we tell in the conic form, boom, we got a parabola? Jamie?
There's an x squared or a y squared.
But never both, right? An x squared or a y squared, but you're not going to get both of them together. Then in the parabolic form, what is the parabolic form, Quentin? There's two different ways to describe the parabolic form.
X minus x1 squared or y minus y1 squared equals 4p y minus 4p x minus x1.
Good, and this is assuming there's a translated vertex, remember. The translated vertex, watch closely, x1, y1, or translated vertex x1, y1, remember. But yeah, this is our conic form that allows for the translated vertex. Now, of course, if it's not translated, it'll just be x squared and y. X squared equals 4py, y squared equals 4px. That's what we've been practicing initially. I think you can use the same Cartesian plane you just used a moment ago unless you have two circles on it, then you might not have room. I don't know. Maybe if you used, a pen or something, maybe you could. I got two parabolas that I want you to graph now on your graph paper. Got y squared equals negative 4x, and x negative 5 squared equals 6 times y minus 1. So analyze and graph both of those. Questions on these? Jamie, I saw we got our axis of symmetry a little off. Did you write x-axis or y-axis?
I wrote y-axis, but then I
Drew
proceeded.
x-axis. Right, so remember my recommendation was anytime you've got a translated vertex, take a moment and draw a little prime axis right away. Well, plot your vertex and then put a prime axis through it, so when it comes time to track the focal length, you'll be doing it on that prime axis. That'll help to guide your eye where it needs to go. All right, any questions at all on what we had talked about up through yesterday's lesson? All right, well, just like with the circle form earlier in the lesson, you couldn't tell by looking at it what the center was or what the radius was, correct? The same is going to be true for the parabola. When it's in the conic form, you're not going to be able to tell right off, oh, this is the vertex, this is the focal length, all of that. We're going to have to get to that point. So, next thing you know is conic to parabolic form. Converting conic to parabolic form. Converting conic to parabolic form. You would write this example down and give yourself some room to work it, but we'll actually, we'll do the, give you some steps at the same time. Y squared minus 4x plus 6y plus 13 equals 0. Why should we know that that's a parabola?
Only one squared.
Only the y is squared, right? I don't see any the x squared here at all. I just see the y squared. So I already know it's a parabola, but it's not in the parabolic form. Step number one, you get the parabolic form, is to get the squared variable on one side and the non-squared and constant on the other. Squared variable on one side, non-squared and constant on the other. Squared variable on one side, non-squared and constant on the other. Now, here's what I want to ask, because you guys are thinking here. What variable is squared? The y. So I want to get the y on one side, everything else on the other. Does that make sense? So it's not just this guy, but his friend, right? They're both y's. I'm going to get them on one side. And the two misfits, they're not y's. They go to the other side as a 4x and a negative 13. Does that make sense? All right, so the squared variable, which would include his first power counterpart on one side, and everybody who doesn't fit, that'd be the variable that only has a first power and the constant on the other. So I want to make sure we're clear on what I mean by those instructions, but I didn't want to be excessively wordy or verbose. Anyway. All right, step number 2. Complete the square on the left. Complete the square on the left, then factor both sides. Complete the square and factor. Complete the square, which will be on the left-hand side, and factor both sides. So obviously to complete the square, we've probably gotten pretty good at this. What is it that goes in the gap, class? The 9. But if I put it on one side, got to put it on the other side as well. So my other side now is going to say 4x minus 4. Do you see what we did there? We completed the square, which would include making sure we add to the other side as well, and then we're going to factor. Now obviously the PST is going to factor into the binomial squared, y minus 3 squared. On the other side, we're going to factor by taking out the common factor, but I need you to jot this down. When you factor out the common factor, you must factor out the coefficient of the non-squared variable. You must factor out the coefficient of the non-squared variable even if it isn't common. You must factor out the coefficient of the non-squared variable even if it isn't common. Now here it helps because the 4 is common. I'm just left with class. But you have to factor out even if it's not. For instance, let's suppose I had a 6x minus 15. I have to factor out the 6. Even though they say, well, 6 isn't common. I don't care. It's got to come out. It's not just, well, there's a 3 common. No, you have to get this because you have to have a plain old x in the first spot. Now, what do you get if you pull a 6 out of a negative 15?
Wait, 2
Negative 15, 6, which happens to be negative 2 and a half, right? But you get the negative 15, 6. You have to pull it out. Does that make sense? Kind of like we did, remember when we graphed sine, cosine, tangent, right? And we had to pull out the b value to figure the period out of the parentheses. Same kind of thing. Even if it's not actually there, even if this were, heaven forbid, a negative 11, well, what do you get when you pull a 6 out of the negative 11? Negative 11, 6, which is negative 1 and 5, 6. So basically negative 2, right? Very close to negative 2 on my x, or positive 2 technically, for my x value. And there we go. Now we're in the parabolic form.
Is it y minus 3 or y plus?
Oh, sorry, y plus 3 squared. I was just seeing if you were paying attention. Good job, Jamie. All right, y plus 3 squared and is equal to the 4 times x negative 1. And then from here, we could do our regular analysis, right? Where is the vertex, class?
1, negative 3.
Good. We were not fooled. 1, negative 3 is our vertex. Which axis is the axis of symmetry?
X.
X-axis. So before we go any further, I'll go ahead and plot the 1, negative 3 right here, and I'm going to put my secondary x-axis through. So make sure my eye is focusing on the correct thing. And what is the focal length?
1.
Positive 1. So we'll go positive 1 here. Of course, the directrix is the y-axis here, and each side of the lattice rectum is 2. The whole length is 4. And so we would get a parabola that looks something like that if we were to graph. All right? Questions on that? Again, squared variable and his friend on one side, all the misfits on the other, so that we can complete the square. That's the principle. We got to complete the square, and of course make sure we add to the other side, do some combining. Factor the binomial squared, factor out the coefficient even if it's not common, and we can do our analysis from there. Write this one down if you would, please. X squared plus 4x minus 8y minus 12 equals 0. Again, I know it's a parabola because
1 squared.
only one variable is squared. By the way, what if, let me change the problem here. What if that were 2x squared? Is it still a parabola?
No.
Yeah, but what do I have to do before I can do anything else?
Factor out.
Take the 2, not necessarily even factor, just divide the 2 out of everything. Knock that 2 out of everything, and then we can do our normal steps, right? So it's still a parabola, yeah. It just take the 2 out because you can't have a number there. But we'll go back to what you had copied down, x squared plus 4x minus 8y minus 12. What do I need to do first, Jamie?
Complete the square? Or well, no,
I'm not ready to do it yet. I want to do it. That's kind of the end goal.
put the non-square very well on the other side as well as the constant.
All right, so what do I write?
X squared plus 4x equals 8y plus 12.
Good. Then what, Quentin?
No, complete square.
By putting,
Plus 4 on both sides.
which of course, this plus 12 plus 4 is really class A.
16.
All right, now that we've completed the square, Jamie,
We backwards. Well, we get x plus 2 squared, and then we factor the a's on the other side to get y plus 4.
we're pulling 8 out of everything. 8y out of 8 gives y, or 8 out of 8y gives y, 8 out of 16 gives 2. All right, and there, we're done, right? We can identify the vertex.
Negative 2, negative 2.
I'm gonna get that one backwards. Anyway, the axis of symmetry,
Y,
the focal length,
2,
and each half of the lattice rectum,
4.
4, and that poor graph grid is so eaten up. We'll draw a quick sketch here. We'll go negative 2, negative 2. We'll put in a new y prime axis here. We'll go up 2 and down 2 to the directrix. We'll go out 4 in each direction, and draw our parabola, it'd be something like that. Do we feel like we're getting the hang of this? Right. Write this one down if you would, please. Y squared minus 2x minus 4 equals 0. This one kind of looks different. Is it really a parabola?
Yes.
Why?
It has only one square.
Yeah, but it doesn't have a y to the first. Doesn't matter, it just says one squared variable, right? So it's gotta be a parabola. What do I do this time? What do you think? Thoughts?
You still move the 2x and the 4 over.
But there's nothing with the y squared.
You just leave it.
Just leave it. It's y minus 0 squared if you wanted to. Remember, we'd see that with the circle as well, hadn't we? So very similar. On the right-hand side, that we do need to factor out the
2.
to get.
X plus 2.
All right. And if we wanted to write y minus 0 squared, we could. I normally wouldn't. I normally just leave the y squared, but maybe it helps you to see it. Where's the vertex?
Negative 2, 0.
Good. Negative 2 for the x, then 0 for the y. Not fooled. Which is the axis of symmetry?
X.
Focal length?
1/2.
A half. Good. And then each side of the lattice rectum?
1.
Tell you what, go ahead and sketch that on your. Tell you what, let's set up a new graph grid. We're going to need a new one anyway for some of the parabolas we're about to do. So let's just set up a new one. It's about time we had a new one anyway. How do the people of Russia feel right now about their president? Quote president, quote unquote. Dictator? What? About time we had a new one. Questions on this one? All right. I want you to do the next one on your own. You can graph it on the graph grid you just used. X squared minus 6x plus minus 2y plus 5 equals 0. All right, questions on that problem there? Good to go? All right. Here's another one for you. Establishing mastery here in this lesson. We're looking at a vertex of 3 halves, or 1 1/2, -4. X-axis is symmetry, focal length 1/2. Each side of lattice rectum 1. So notice, by the way, since all of them have the same lattice rectum length, 2, they're all basically the same thing. They're just pivoted and placed differently, aren't they? Congruent parabolas. All right, questions on that? All right, in your textbooks, page 237. Page 237. Break open the textbooks for the first time in a couple days. Page 237. I want to get another sheet of graph paper ready, and I want you to do number 9, B, D, and F. Page 237, number 9, B, D, and F. Again, set up a new Cartesian plane. Let's do all 3 parabolas on that same Cartesian plane. But I feel like 3 is probably about our number. I don't know that we could do more than 3 and tell what's happening after that. I'm not a perfectionist or anything. All right, how do we do? With the analysis, with the graphing? Feel like we're getting the hang of this? Good. Excellent. Next lesson. Probably have opportunity to show me just how good you are. I know you're excited about that. A little sarcasm there. All right, page 237 for homework this evening. Page 237, doing number 9, A, C, E, and G. Page 237, number 9, A, C, E, and G. Take a look at all of those in our next lesson. Have a wonderful rest of your day, and you are dismissed.